Good afternoon. Today I'm going to present my medical insurance cost prediction project. In this project, I build and evaluate a machine learning model to predict insurance charges using demographic and lifestyle information. So the first one is project overview. The goal of this project is to predict medical insurance charges based on several features, including age, sex, BMI, number of children, smoking status, and region. This is a regression problem where the target variable is continuous. My main objective were to build accurate regression model, to properly validate model performance, to analyze model fits using learning curves, and to generate prediction for a Kaggle submission. And now is the dataset description. The dataset contains two parts, a training set and a test set. The training data include about 1,300 observation in 7 columns. The features include age, sex, BMI, number of children, smoking status, and region. The target variable is medical charges. Some of these variables are categorical, such as sex, smoke, and region, which need to be encoded before modeling. And now here is the data reprocessing. Before building models, I performed processing using a pipeline. First, I separate the feature and the target variable. Then I divide the feature into two groups, categorical variable, sex, smoker, and region, and numerical variable like age, BMI, and children. For a categorical variable, I apply the one-hot encoder. For numeric variable, I use path-through without scaling because tree-based model do not require normalization. I implement all processing steps using column transformer and pipeline. This approach helps prevent data leakage and ensures consistent processing during training and testing. And here's the baseline model, linear regression. I implemented an random forest regression to improve performance. Random forest is an ensemble model that combines multiple decision tree and can compute nonlinear patterns. I use the same pre-processing pipeline and turnkey. Hypermeters include number of trees like 300 and maximum depth in 10. After training, the random forest model achieves validation MSE around 21 million and validation RMSE around 4,600. This present a significant improvement over linear regression. Therefore, random forest was selected as the final model. And here is my group mate Xixian will compute the next part.
Okay, for the next part, to evaluate model performance more reliable, I use a multiple validation method. First, I apply tree validation split with an about 80 to 20 ratio. Second, I use a five-fold cross validation to estimate average performance and availability. Cross-validation results were consistent with the validation split, which indicates that the model performance is stable and reliable. This validation method helped ensure that the model generalized well to unseen data. And okay, let's move on to the next part. To analyze the model fit, I plotted the learning curves. The learning curve shows training and cross-validation error as the training set size increases. From the plot, I observed that training error is much lower than validation error. There is a large gap between the two curves. Validation error decreases gradually with more data. This pattern indicates overfitting. The model fits the training data very well, but its generalization ability is limited. However, since the validation error decreases with more data, adding more training samples may further improve performance. To reduce overfitting, I limited model complexity using max steps and cross-validation. And after selecting the final model, I retrained it using with a full training dataset. Then I generated predictions for the test dataset. I created a summation file with two columns. First is ID and second is predicted charges. This file was submitted to Kaggle for evaluation. The submission process verifies that the model pineapple works correctly on user certain data. And in conclusion, this project demonstrates a couple machine learning workflows for regression. So key steps included data preparing using the pipelines and the baselines and advanced modeling, performance validation, learning curve analysis, and Kaggle submission. And among these test model, random forest performance the best. Future improvements could include more hypermeter turning, training, gradient boosting, or XG boost, using log transformation on charters, collecting more training data. Overall, this project helped me and my teammates understand how to build, evaluate, and improve regression models in practice. So thank you for your listening.